Hello, ladies and gentlemen, and welcome to the first episode of our 10 episode series on We CAD Do It, CAD and Design in Autodesk Inventor. So we're going to go ahead and get started. I'm going to go ahead and share my screen here. So this is the Autodesk Inventor Professional landing page. I have used this before. Originally, I had made the original episode a while back, but unfortunately that file was corrupted. So as you can see, I already have a lot of stuff set up here, but hopefully I can still break it down in a comprehensive manner. So let's get started. So firstly, what I'm going to go here and do is in the top left corner, you can see that we have a projects little tab here. So project is essentially just going to be a repository where we can keep all the files for a particular project. Maybe you're building your gravity vehicle, or your mousetrap vehicle in Autodesk Inventor. That's something that I would do when I was a bit younger, competing myself. Or you might be building something I also did, building your Mission Possible device. Maybe you have some parts that need to be 3D printed. So you can download assemblies, which we'll talk about in a future episode, of various pulleys and parts and moving components, as well as building some components to put it all together, make it all work, and then 3D printing. That's also an equally viable option. So CAD design is not just useful for events like We CAD Do It, but also intensely useful for Science Olympiad. And so that's why I have no doubt that a majority of you have experience in CAD design, maybe not necessarily in Autodesk Inventor or any CAD or any sort of CAD software that I might talk about in general, but maybe you have experience with something like AutoCAD, OpenSCAD, FreeCAD, etc., or maybe some other, as we talked about in the initial episode, non-parametric. Maybe you have experience in non-parametric, so not talking about three-dimensional stuff necessarily, CAD. So that being said, let's go ahead and get started. So you have three panes here. As we talked about already, you have projects. This is just a listed group of projects. If I wanted to create a new project, I'm not going to. I'm going to use CAD event day one. But go to projects, and I can go ahead and, as you see here, I can go ahead and click new. Then single use project is for one person or usually one device, one person or one device. New vault project is just a project that's limited to a particular group of people, but generally it's for more than one person that can be shared across different devices. So single user project, you would go project name. I'm going to call this CAD event, not day one. I'm going to just pretend that this exists. Then I go to next. So this is in importing any libraries. In this case, the only one that I have is Inventor Electrical, which imports various features of electrical engineering that we could use. In this case, or in your event, you're not going to be using anything in Inventor Electrical, or if you're just a hobbyist, very rarely will you use Inventor Electrical. You're free to experiment with that library on your own time, but I will not be using the library. So I would normally just click finish, and then it would pop up and I'd be able to click on it. I'm not going to do that. I'm going to go ahead and cancel that. And I already have CAD event day one selected. And now if I were selecting a new one, let's say I wanted to select Inventor Electrical Project, I just click apply, and then it would switch it over. Same thing, I'm just going to switch it back, click done. All right, great. So now you have a variety of new things I can make: assembly, drawing, presentation, or part. I will not be talking about presentations in this 10 episode series unless I am asked to do so. You won't be needing this. You'll very rarely be needing presentations. I personally have never used them before, but these other three file types are very important. So parts are just one component as visualized here, as you see in an assembly. Parts are multiple components, and then drawings are essentially going to be sketches, kind of the blueprint of how you would want to make a part. And the idea behind a drawing is that if I create a drawing and I give it to you, you should theoretically, if you have all the proper machines that you need to do so, you would be able to machine that part without 3D printing it or feeding the file to a device. So let's go ahead and get started by creating a brand new part. I'm just going to create a new part here. And today we're going to be talking about two-dimensional sketch tools. So let's go ahead and jump into just what our whole layout is going to be like. So you have a lot of different moving parts here, but don't worry too much about it. Firstly, we're going to talk about our hotbar up here. has a bunch of different tools, most of which you probably won't need to use. As you can see, as you'll notice later on, you have a lot of tools that might be repeated. Trim and extend here are tools that you're going to see very often for a variety of different things. You'll see trim and extend for 3D sketches. You'll see trim and extend for 2D sketches. You'll see trim and extend for 3D objects, etc. So you'll basically see a lot of different items. In this case, it's going to be planes and faces that have the same sets of tools and operations you can do on them, as well as a variety of stress analysis and figure analysis that we'll do later when we get to a discussion about finite element analysis later down the line. So as of now, we're not going to be focusing on the 3D model tab. We're going to be focusing specifically right here on the sketch tab. 2D sketch, not 3D sketch. That's for one of our later sections. And as you can see, as soon as I click Start 2D Sketch, it's going to take me here to an orthogonal setup with 3 planes. So as you can see in the bottom left corner, I have these cardinal directions. So you have X, Y, and Z direction. And as you might imagine, you have the X plane, the X axis. Oh, sorry. We have the X axis. You have the Y axis, Z axis, as well as X, Y, XY, XZ, and YZ planes. All right. And then I also have this cube here, which I can click and drag around. I'd highly recommend using a mouse for this. Click and drag around to view the object from different perspectives. Awesome. All right. Great. So let's go ahead and get started here. So I'm going to click Start New 2D Sketch. I click there. It's going to take me to this automatic isometric view of these planes, which means that it's being viewed from a topish angle around here. So you can see all 3 planes. We're going to click. I'm going to start with the XZ plane here, since that's our flat plane, and it's going to normal direction to it. So here's what we're going to do. We're going to go over these very basic 2D sketch objects, starting with the line tool. So the line tool, very simple. So as you can see, as soon as I click it, it's going to give me a nice yellow dot I can drag around, and it's going to give me the X and Y coordinates on display. So this is essentially giving us what's called a position vector. So a position vector is going to tell us that if I were at the origin and I needed to get to whatever point I have here, this yellow dot that I'm moving around, not the one that's stationary, this is the origin. If I wanted to get to this yellow dot, how would I have to move? In this case, I might have to move in the positive X direction by 0.485 inches, and then in the negative Y direction by 0.585 inches. So that's the information that it's conveying, and it would tell us the X and Y components of a line that we would make if we made a line from the origin. And then the origin, naturally, if you click over it, it's going to turn green, and it's going to tell us that this is 0, 0, essentially meaning that you would just be creating a point. So when you create a line, you click 2 points, the starting position and the end position. And then you can continue clicking until you are satisfied with how many lines you made. Then you can just hit escape and it will stop making lines. All right. But something very cool about these lines is, let's say I made a line, it is constrained to this plane here, to this axis, in this case, the Z-axis, negative Z-axis. What I can go ahead and do is I can actually change the dimension or the length of it by using the dimension tool. And this will constrain it. Let's say I want this line to be 1 inch, stay at 1 inch. I can go ahead and do that, and that will stay at 1 inch. Now, let's say I wanted to use the circle tool. Well, the circle tool, at least in this case, has a center. And then the second click will define the end of its radius and will define the full circle. And I can go ahead and say that the radius of the circle, or in this case, the diameter of the circle, except might see that the diameter of the circle is equal to, I can't constrain it, but is equal to the length of this line. And this provides a constraint here, as you can see. So what is this constraint? Well, a constraint is something that will limit the sketch in its ability to move. So in this case, when I went over here and I clicked on this point, it identified that I wanted this line here to be the radius of the circle. And as you can see, this has now been switched to have a coinciding constraint. So that this point should always be both at the end of this line, and it should always be on this circle. So if I went ahead and changed the length of this line, should, in theory, which is correct, change the radius of our circle. And there are plenty of other constraints I could have here. Let's say I want to create another type of shape, an arc, which is just part of the circle. In this case, the arc is defined by a midpoint, by having the radius of the supposed circle that would be part of the arc, as well as now the length of the arc. So I could do that. Then what I could go ahead and do is I could use the tangent constraint, tangent up there. And now the circle that would exist based on this tangent would now be tangent to this. Now that sounds a bit confusing. And what that essentially means is if I were to use this tool here, the extend, which will extend anything to the next closest point, it will extend and be tangent to this circle right here. And if I have a line, this is sitting out here, it will be tangent, tangent to this circle. Finally, there are plenty of other constraints here, some that we can talk about, but most are pretty simple. I can talk about the vertical constraint, which will make sure that a line is vertical, as well as a horizontal constraint, which will make sure it's horizontal. Technically the opposite because we're looking at the z direction in this way, but my point still stands. So we also have the equals constraint. Let's say I wanted this to be equal. These two would in fact be equal in length as well as in direction. Sorry, these are parallel. These would be parallel. And then if I want them to be equal, I use the equal constraint to define them at the same length. And finally, I'll just discuss the fix, which you can use to fix any object in place. Let's say that I want to fix this point here. Cool. Now, if I want to change this, now if I want to change this point, I wouldn't be able to because it is constrained as fixed. Oh, and also parallel. But if I remove the parallel constraint, then I would not be able to move this point here because this is fixed. All right. Great. So now we have gone over basic constraints. We have gone over 2D sketches, as well as going over just the general layout of the SolidWorks, sorry, of the Autodesk Inventor landing page. Finally, before we go, I will talk about the variations of each tool that we've discussed here. So rectangle should be pretty self-explanatory. It just creates a rectangle. You select one corner of one rectangle, and then it ends by being another corner up here. But there are different variations that you can experiment with of each tool that may be useful. For a line, you have a spline tool. We can define various inflection points, which are points where it changes whether it's going up or down, or whether the slope is increasing or decreasing. Here. But you can also have variations of a spline, which is just a skinny, a non-straight line. We can define points, which it again has inflection, which again where it switches from the line increasing in size, increasing in the positive direction, or decreasing in the negative direction. Overall, the best experience you can get with CAD is just to play with CAD. That's the best experience that you can ask for. So definitely don't shy away from experimenting with all of these different options and getting a feel for which ones would be important in certain situations. So the example is the tangent circle, which will create a line, create a circle that would be tangent to 3 lines. Notice that this circle is not necessarily tangent to this line, but if I went ahead and used the extend tool to extend this line, it would eventually be tangent at one point here. I can also use the trim tool to make something shorter. Let's say I wanted to make this, this circle shorter so that this sector here, this arc here does not exist, I can go ahead and click that and it will eliminate that part of that circle. And there are variations of tools like the rectangle tool. This one would define the center as opposed to a corner. And then I can define one of the corners and so on and so forth. And it will be important to know this for later so that you can use different variations of each tool to your advantage depending on what you need to accomplish. So now we've discussed basic sketch tools. And in the next section, we will talk about making a small tin can based on a predefined model that I have made and being able to talk about making three-dimensional objects based on two-dimensional sketches. All right, thank you everyone, and I will see you next time.